a look at comparing functions, specifically looking at graphs between linear, exponential, and quadratic. So we're going to make a tab, so cut it all the way across, and then the first tab, cut it to the margin all the way down. We're going to label that graphs, and the title page is going to call comparing functions. Let's pause the video and copy this down. You need to copy it down exactly. I'm not going to give you credit for a sketch, so look at the parts that I've marked and copy it down exactly. Alright, so let's take a look at a linear function. So linear function is a straight line. It gives you a constant change. It changes at a constant rate. Exponential function, it either starts off slow then takes off, or if it's coming down, it drops really quickly and then it tampers off. Okay, so it'll always be like slow and then quick takeoff, versus linear where it'll just be a straight line. When you look at a quadratic, it either looks like a U or it looks like an N. This is a listening check. Color in looks like a U or N. So U if it's positive, it's an N if it's negative. Alright, let's take a look at domain and range, because I know we're still kind of struggling with that. Domain is your X. Okay, so looking at just the X, if I extend the line in both directions because there's not enough graph, and then I move from left to right, is there a graph all the way on the left? Yes. As you extend it, there is. Therefore, negative infinity. Is there a graph all the way on the right hand side? Yes. Therefore, positive infinity. Another way you can say that is all real numbers, meaning everything. Alright, so I'm just going to color in the x-axis because that's the way you're looking left and right. Range is going to be y, so take a different color and we're going to look up and down. Is there a graph everywhere? So I'm going to color in the y-axis and then look at the bottom. Is there a graph? Yes. On my extended, there's a graph. Even if I keep going down, there's a graph. If I do the same thing to the top, it will be the same thing. So I have all real numbers is also my range. All right, let's take a look at another one. All right, so again, domain is X. I'm going to color in my X. So here's my yellow. All right, then I'm going to extend my line. Okay, see, I'm extending my line for my graph. And then I'm going to look all the way on the left. Is there a graph? Yes. I'm going to look all the way on the right. Is there a graph? Yes, it goes off the paper, but there is a graph. So for exponential, again, my domain is all real numbers. And here's a little like shortcut for you. For exponential, it's always domain all real numbers. Same thing with the y. So you see down here, there's no graph, right? Up there is where the graph starts at 0, but doesn't include 0 because there's an isotope at that point. So my range is an open parenthesis, doesn't include 0 because it's an open. There's an isotope there. And then it goes on forever up because every point, even all the way at the top here, there's a graph on the right hand side. So to infinity. So these are numbers bigger than 0 as your range. Alright, same thing, domain is X, so go ahead and color in your X. And then look on the far left hand side. Pick a point. Is there a graph on that far left hand side? Yes. Pick your far right hand side. Is there a graph on that far right hand side? Yes. So your domain is from negative infinity to infinity, or you can write it as all real numbers. Range, so color in your y-axis. Start at the bottom. Is there a graph there? Nope, 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 nope. Yes, it starts right there. And it includes that point because there's no isotope there. So it starts at this point there. Closed because it includes that point, and it looks like it's negative 2.3. And then, is there a graph up here? Yes, in fact, it's in 2 places. It goes on forever, so that goes to infinity. Open on infinity because it doesn't include it. Okay, so domain is X, range is Y. Now we're going to take a look at rate of change for all of them. So rate of change in the interval. What you need to do is really just, well, what is rate of change? Change in Y over change in X, which is Y2 minus Y1 over X2 minus X1. Okay, so label your points. I've got X1 and X2, and those are not X and Y because they're close parentheses. And then we just have to find out what Y2 and Y1 are. So let's go look at it. So you go to 0, what's that value? Go to 2, what's that value? And you just plug it in. So that point up there is 0, 4. This point over here is 2, negative 1. And now we're just plugging it in. So if what goes with the 2 is negative 1, what goes with the 0 is 4. And then just use a calculator, and you're going to get negative 5.2. Alright, so let's do another rate of change problem. So same exact thing. We're going to label x1, x2. Then you're going to look at that point. So at x1, at 0, what is y? And then at 2, what is y? This is a listening check. Color in the triangle after rate of y2 is 25 minus y1, which is 100, over x2, which is 2, minus x1, which is, get in the calculator, and when it gives you a decimal, press math, enter the correct fraction. Final example, same thing, rate of change over that given interval. First label it x1, x2. We find y1 and y2. So when x1 is 0, y1 is 0. When x2 is 2, y2 is 4. And now you just plug in the numbers. Just plug in the numbers, put it in your calculator, and you're going to get to it. Make sure it's always simplified. You get it wrong if it's not simplified. That's pretty much it. So that's linear, exponential, and quadratic. Let's practice.